This question is asking us to find the values of each of these trig expressions. Now it's important to note that these triangles have three unique sides. One's going to be the adjacent side, one's going to be the opposite side, and then one is going to be the hypotenuse. Now the hypotenuse is always the longest side of the right triangle, and it's going to be across from this 90-degree angle. So this side right here that's labeled 25, that's going to be the hypotenuse. And it also happens to be the first one that I like to identify. The next one I like to identify is the opposite side. Now this one depends on where theta is. So theta is down here in this corner. So the opposite side is going to be across from theta. So if I draw a line from theta to a side, that side's going to be the opposite side. And then the leftover side right here is 20. That's going to be the adjacent side. It means the side that's closest to this angle right here. Now it's also important to note that the hypotenuse is also kind of adjacent here to this theta, but the hypotenuse is always going to be the longest side, so it kind of trumps all other definitions. Anyways, I'm going to erase these couple arrows here, and I'm just going to leave the opposite side. So here we go. 25 is the hypotenuse, 15 is the opposite side, and 20 is the adjacent side. And now we just want to set up all of our trig ratios up here. So sine of theta is going to be opposite over the hypotenuse. So the opposite side is 15, and the hypotenuse we said was 25. So the next step would be to simplify this or reduce it. And 5 divides into both of these. So 15 divided by 5 is 3, and 25 divided by 5 is 5. So this is going to be the answer for sine of theta. Cosine of theta is adjacent over hypotenuse. So the adjacent side we said was 20. So I put 20 down for the numerator, and again the hypotenuse is of course 25. We could reduce this one as well. 5 goes into both of these, so 20 divided by 5 is 4, and then 25 divided by 5 is 5. So this is going to be the trig ratio that matches up with cosine of theta. And lastly, tangent of theta is opposite side over adjacent. So opposite side is 15. We use that with sine. And then the adjacent side is 20. We use that with cosine. And we could also reduce this. 5 goes into both of these as well. So 15 divided by 5 is 3. And 20 divided by 5 is 4. So this one's going to be 3/4. Now part B is going to be done the same way as part A, except theta is in a different place. So maybe we could figure out if that changes anything. Now the first thing that I would always identify is the hypotenuse. So again, this is the longest side, it's 25 as well. And then the side that's across from theta is the opposite side. So the opposite side here is going to be 20. Unlike this one, the opposite side was 15. So it does look like theta changes some of our values here. And then the last side here, 15, is the adjacent. It's the side that's next to the theta. Okay. Now we want to figure out what our trig ratios are. Sine of theta is opposite over hypotenuse, so opposite side was 20 over 25, which is the hypotenuse. So I'm going to write this in here. You could reduce this by 5, so we're going to end up with 4 over 5. Cosine of theta is adjacent over the hypotenuse, so that's going to be 15 over 25. And if I reduce this, I'm going to have 3 over 5. Tangent of theta is opposite over adjacent, so that's going to be 20 over 15. And I could reduce this because 5 goes into both of them. 20 divided by 5 is 4, and 15 divided by 5 is 3. So these three fractions right here are the ratios that match up with these three trig expressions. Now, as you can see, we had the exact same triangles right here on the left and right, but theta was in different spots. And did that change the value of sine of theta, cosine of theta, and tangent of theta? Yep. They're similar, but they're definitely not equal. Lastly, part C, we have just sine of theta. We're going to do it the exact same way. The first side I'm going to call out is the hypotenuse. That's the longest side, so I'm going to highlight that right here. And remember, that is across from the 90-degree angle all the time. That doesn't change. And then I like to draw a line or an arrow from theta to the opposite side, and I could see that 7 is going to be the opposite side. That leaves 24 right here being the adjacent side, the side that is next to theta. So to find sine of theta, we use opposite over hypotenuse. So according to theta, the opposite side is 7. We already figured that out. And the hypotenuse is, well, I don't know. I don't have a value over here, right? So some cases you're gonna have to find that missing side. So I'm gonna go ahead and call h, that's the variable, so we'll just use that, I guess. So that's going to be the unknown value in the denominator. And I use the Pythagorean Theorem because I have two legs of this right triangle, and I could use that theory to find that hypotenuse. So I'm going to set that up. I'm going to use a squared plus b squared equals c squared. That's the Pythagorean Theorem. And then I plug in my legs of my right triangle for a and b. And it doesn't matter which one's which. It's just got to be the legs. And then the hypotenuse, well, let's change this to h, because the equation is always set equal to the hypotenuse squared. And if you're confused about what are the legs and what's the hypotenuse and whatnot, just think of a right triangle here, right? And having an array going up and then an array going this way. These are the legs. That's one leg and that's the other leg. And then you have this hypotenuse coming in, which is another line here, and that's going to be h, right? So this is a leg, and then the longest side here is the hypotenuse. Now back to this equation. To solve it, we're going to square 24 and square 7. That gives us 576 plus 49. Then we could add them together. That gives us 625. And then to get rid of this squaring right here, the opposite thing to do would be to take the square root of it. So there's the square root. The answer for h is going to be plus or minus 25 because that's the square root of 625. But we're only going to use the positive version, of course, because we have the side of a triangle, and the side of a triangle can't be negative. And we're going to plug that in for h right here. That's going to be a final answer of 7 over 25. So we set up our trig ratio to start, but we had a missing value for the hypotenuse. Sometimes that happens. If it does, and as long as you have two of the other sides, you could use the Pythagorean theorem to find that missing side.